Thank you, everybody, for coming. This is a talk about the Play framework at LinkedIn. And let me set the context a little bit here. So you're a developer, and you're using Java to build web services. This is your life. You spend an awful lot of time just waiting for a service to redeploy. There's numbers that show that some Java developers spend a quarter of their time waiting for their server to redeploy. You hire 4 guys, 3 of them are actually working. It's mind-boggling. How many of you spend time tailing Catalina.out or some other log file, digging through just enormous stack traces that are incredibly hard to parse? You know, you think you use, I know the Java language, I know Scala, I know JavaScript. You have to speak stack trace as well to really be effective at Java. You spend a lot of time in XML soup. Probably not too visible from back there, but Spring files, config files, and just mountains and mountains of XML without any really good tooling to make any sense of it. You deal with classes like this. This is one of my all-time favorite classes, I think, ever. It's part of the Spring framework. It's called the Abstract Singleton Proxy Factory Bean. And the description makes it awesome. It's a convenient proxy factory bean superclass for proxy factory beans that create only singletons. Love it. It's so awesome. You occasionally run into thread pool hell. For some reason or another, you start running out of threads, the latency on your server goes crazy. And that's really what it's about. That's what Java web development has been for a very long time. It has just been pain. So there is a better way. And it's called Ruby on Rails. No, I'm just kidding. We have some real work to do here. So no, it's called Play Framework, which is a modern web framework for Java and for Scala that I think just lets you have all the stuff that you're used to with Java, the type safety, the IDE, the performance, the JVM, with far less pain. So I work at LinkedIn, world's largest professional network. We have 225 million members. There's more than 2 people joining every second. So by the time I'm done rambling here, 7,200 or so people will have joined. So it's a pretty good scale. So we've been using Play in production for about 6 months. So we're still pretty new to it. We're learning a lot, but we kind of are excited about it, and we want to share it with all of you guys. And a few of the apps you may have seen from just a few months of work, we launched Channels, which is part of our influencer platform. All sorts of important people are blogging and sharing things on LinkedIn, and this is a great way to kind of break it down by category and follow the channels that you're interested in. One of our monetization products, Premium Subscriptions, is built on top of Play, and they have all sorts of cool visualizations. Polls, the front end and the back end, polls and groups, and a few other places was built on top of Play. And we have a ton of internal tools that have just popped out of nowhere just because it's so quick to get started and just get something up and running. This is an internal tool to search our internal RESTful services and figure out how to call them and get data from them and things of that sort. So that's just from a few months of work. There'll be way more in the future. I'm Yevgeny Brickman, or I go by the nickname Jim for people that have trouble pronouncing Yevgeny. And I'm part of our service infrastructure team. I'm leading the project that's bringing the Play framework to LinkedIn. And really this talk, it's going to be about building web services at massive scale using Java and Scala while maintaining performance, reliability, and developer productivity. And this is a very tricky balance to kind of achieve. Very few frameworks are really able to do it successfully. Usually they give you one or the other, but rarely all 3. So this is kind of an outline of what we'll do. I'll give you guys a very quick kind of getting started with Play. I'll do some live coding, which should be interesting, show you what it looks like to actually use the framework, error handling. I'll talk a little bit about Play's kind of evented or reactive model for handling I/O. I'll talk a bit about Scala, talk a bit about performance, and the community. So a lot to get through. Let's get started. So those of you guys who want to try out Play, it's really easy. Grab it from playframework.com. It's really easy to install it. To create a new app, you just run play new and then give it the name of an app. To set up your IDE with all the dependencies and classes and jars and everything that you need, there's just another command, play idea or play eclipse, depending on what your IDE is. And to actually run the app, it's just play run, and it'll fire up and by default listen on port 9000. And if you hit a page, you get this nice intro page. If you've used Rails, if you've used a bunch of other frameworks, this should feel like a very natural way to start a new app. If you're used to other frameworks, maybe not so much, so this is actually very easy. It takes just a few minutes and you're up and running. So I did this, I have it running in the background. Here you can see, I don't know, some console stuff, and the app is running. And I also have it loaded in my IDE. So what I'm gonna be able to do now is actually code for you guys a little bit, and if the demo gods are kind, hopefully show you a little bit of what it's like to actually use Play. So Play uses kind of an MVC pattern, model view controller. Again, many frameworks do the same thing. If you've used anything like Rails, this should feel right at home. So we'll create a controller, which is just a Java class. We'll start with a basic hello world example. And to get some nice helper methods, it can extend the controller class from Play. And inside of your controllers, you basically have actions that return some kind of a result. Not the most original class name, apparently. And so in here, we need to return some sort of result. The simplest one is a 200 OK. And you can do that using this OK method that's in the controller class. So this actually is kind of the hello world example. We can put some text in it just to make it a little more interesting. So the only thing we need to do besides this is just expose it at some kind of a URL. So there is a routes file in here. And the syntax for the routes file is the HTTP method that you're interested in, get, put, post, etc. The URL pattern, so we'll just put this at hello. And then quite literally the code to execute. So in this case, it's controllers.helloworld.index. That's it. If you now go to your browser, go to this guy /hello, hit enter, you can see in the background it's already done, but if you scroll up a little bit, it compiled all the stuff on the fly, reloaded the server. I have a bunch of plugins in here that I'll start it up, but basically you get your hello world example. We can make this more interesting. Let's read a parameter out of the query string. So maybe we'll read the name out of the query string, just add it to the routes file. And this just gets passed to your action as a function parameter. Or, sorry, this should be called name. And so now we can do something hello plus name. Oops. There we go. So now I can just add that guy onto here. You can see I've tried this example before. We hit enter, give it a second, and now it says hello, Jim. And so now we have a slightly more dynamic example, and we can change this to Bob or whatever we want. We can also, Play has some really cool routing stuff. If you like kind of SEO-friendly URLs, you can actually make the parameter part of the URL as opposed to part of the query string. So this is kind of the syntax for saying the thing after hello / call it name. So now instead of doing it as a query string parameter, I can do /, let's change it to Steve so you can actually see something happen. So it reloads, and now it says, hello, Steve, and it's reading it out of the URL. Parameters have types. After all, we're using a type-safe language. We should take advantage of it. So we can add another parameter, maybe the age, and it's an integer. So now we can say, hello, name, you are age years old. And so now let's add another part to our URL here, fix the spacing a bit. And so I wrote here just name, but this is really just shorthand for something that is a string. If you actually want these things to have different types, you just specify the type after the parameter. This is, you can see now it's all compiling and IntelliJ's happy. Technically, the syntax on this right side here is Scala, but you don't really need to know much Scala to make use of it. So we can now say that Steve is 55 years old. And it'll reload the changes, and now it says, hello, Steve, you are 55 years old. And this has type checking. So if I put in some garbage in here that's not a number, it instantly tells me it's not a number, which is very handy, using our type safety to our advantage. OK, let's, one more thing we can do. I showed you guys the giant blobs of XML all over the kind of servlet universe. Play, for its config system, uses type-safe configs, which are in these .conf files. And essentially, these boil down to JSON, but it just gives a couple extra features on top of it. So you can include other files, you can reference other configs, you can use this key almost this properties file syntax, or you can just put JSON in here. It's kind of up to you. So where am I? I am at JaxConf. And so in here, to this example, I will read a config, and you'll see that it can hot reload config changes as well. So my location is get string, location is the name of the config, and you are at location. Can you guys still see that? Hopefully you guys can read that. Refresh the page, it's gonna reload the config changes when this thing comes up, and there we go, you are at JaxConf. So really end-to-end hot reloads. Java changes, Scala changes, config changes, whatever you're working on, yeah. So first question, I knew you were gonna ask it. If you actually look at my slides, don't worry about static. Ta-da. Okay, so Play has a philosophy with controllers that the actions should be static because there's really just one controller. It's kind of like a switchboard operator. If you don't want to use it, you can instantiate the controller on every request. You can do injection. If you really want to, you can use Play with Spring, with Google Juice, whatever you want to. Using static here is just the fastest way for me to give you guys a really quick demo. So don't panic. You can still have IOC and all the kind of stuff that you're used to. Your other question was as annotations, right. I don't think so. I think the default routing framework uses the routes file. That said, removing the default routing framework is one line of code, and then you can swap in your own. Literally, there's a method called onRouteRequest. It gives you the request. The default implementation uses the routes file. If you want to do something else, you absolutely can. And we actually did that. For some of our backends, we have custom RESTful routing. It's a framework called Restly that's open source, and so we actually use that on top of Play by doing exactly that. So it's actually pretty easy to do, to swap that out. So configs are hot reloaded, which is awesome, but let's render a view. I'm tired of rendering things inside of my controller. This is kind of not so cool. So let's create a view. Play built in has these things called Scala templates. We use Play at LinkedIn with Dust.js. Happy to follow up after the talk if anyone wants to know how that works. So we'll create a new template in here. And in here, I mean, just like any templating language, you can put your usual markup. The difference is Play will actually compile these Scala templates into a function. So these are also actually type safe, which is pretty interesting. And you can take in parameters in that function using this syntax at the top. So let's say I want the same name, and I want the same age parameter. So now those are going to be parameters to this guy, and now I can do something like hello, let's make it bold, name. You have autocomplete in here as well. You are age years old. And I don't know, let's put a picture in here as well, just so we know it's really a view being rendered. Assets. Play has really nice type safe generation of URLs as well, but I'll demo that if we have time at the end. Okay, so I have a view that's just going to have a logo and say, hi, you are so many years old. So now we just have to actually render it from here. So you do that by doing this, oops, views, render, and you pass it the name and the age as parameters. I haven't compiled this view before, so right now it looks like an error, but as soon as I refresh, IntelliJ should pick that up correctly, and it should render in the browser if the demo gods are kind. Hey, there we go. So Play logo, hello Steve, you are 55 years old. Can obviously tweak these parameters. Steve just got really old. And you can see in my IDE, if it updates, there we go. So now it recognized that everything is compiling, you have type ahead, everything is just very nicely integrated. So that's a really basic intro to working with Play. I'll do a few more demos in a bit, but this is kind of this MVC architecture. One of my favorite things, I showed you guys a really brief demo of it, is Play has amazing error handling so that I don't have to sit there and tail logs all day long. So let's say I forgot a semicolon. I mean, obviously IntelliJ shows me, but pretend you have some silly compiler error. If I refresh the page, Play shows me immediately in the browser what the error was, what file it's in, what line, and the actual busted source code right here. I don't have to go digging for it in some console. It's also, by the way, in the console if you do need the full stack trace, but in most cases you just see the error in the browser and you go and fix it. So I can fix it, and this applies pretty much everywhere. If I mess up the name of one of these variables in here, again, IntelliJ is smart enough to show me, but if I miss that for some reason, Play will show me in the browser where that mistake is. And so this applies to templates, to Java, to config. Again, end to end, the errors show up in the browser. You do not have to exclusively understand how to read mile-long stack traces to know what's going on in your app. Really powerful feature. Okay, so that's a really basic intro. By the way, I had a bunch of slides here just in case the demo decided to blow up in my face, so I'll skip all of those guys. And we'll go to the next topic here. So besides being very developer-friendly, Play does something else quite a bit different than most Java frameworks that you're probably used to. Most people are used to what I would call threaded servers. By the way, this is a very high-level overview. I'm obviously glossing over a lot of details, but bear with me. So most people are used to threaded servers. What I mean by that is a request comes in, and the server will pick out of a thread pool a thread, assign it to that request, and it's going to process the request until it's done, ship the response, and then put the thread back in the thread pool. So one thread per request. And it usually also involves a lot of blocking I/O. And this is almost every common framework out there today. So Spring MVC, Grails, Django, PHP, Rails. Did you guys know that was Tomcat's logo, that weird cat-looking thing? I've been using Tomcat for years. I had no idea that weird thing was its logo. Anyway, Tomcat, all of these things are threaded blocking servers. And so the code typically looks something like this. You have some kind of method, doGet, and you have, for example, the Apache HTTP client, and I'm going to make an HTTP request to example.com, and when I call that execute method, literally the thread is going to shoot out that request, and it's just going to sit there blocking and idle until the response comes back. That thread doesn't do anything else until the response comes back. And when it does, then the next line of code executes, which has some downsides that I'll discuss in a minute. So the alternative to threaded servers are evented or reactive, or there's many names for them, non-blocking kind of server architectures. They're not new, they've been around forever, but they're gaining popularity for kind of mainstream web services. I'm sure all of you guys have heard of Node.js. It's completely non-blocking. Play is built on top of Akka and Netty, although you can use obviously those pieces by themselves. Both are kind of ways to do reactive non-blocking code in Java. And an example, so from like the Node.js world, here's a typical non-blocking case. This line down here, http.request. That's kind of the equivalent of HTTP client. You're going to fire HTTP request to some server, but it's completely non-blocking. That happens almost instantaneously, and the next line of code executes before the response has actually come back. The response is not available until somewhere at some point that callback function is executed. So the code doesn't really read top to bottom, but there's also no blocking, so the thread can go and do other stuff. So why do we care? Why, especially at LinkedIn, do we really care about this threaded versus evented trade-off? So the reason is we use a service-oriented architecture. What that means is that our code, our website is broken down into a bunch of standalone services. You can write the code for them separately. They can deploy to separate hardware. You can scale them separately, iterate on them completely separately, and they talk to each other through usually some kind of remote call to maybe a JSON, RESTful endpoint. And so as you can see, front ends talking to back ends talking to data stores. There's obviously an enormous amount of complexity that's being glossed over here with mid-tiers and caches and lots of other stuff. But at the end of the day, servers spend an awful lot of time just calling other servers. So this is maybe a typical front-end servlet we would have, and most of what it's doing is it's going to call our profile service to fetch profile data. It'll call the company service to get company data, the skills service to get skills data, and every time it does this, it just sits there and waits for the response, and that thread can do nothing else the entire time. And of course, you can do some of this asynchronously even in a threaded server, but to do that, you have to set up another thread pool, and you have to submit work to it, and then you have to block until that work is finished, and you have to manage concurrency. So again, nothing that I'm saying here is impossible to do, it's just a lot harder. And here's the thing. This is an awesome chart. By the way, those numbers at the end, the 4, These are references at the end of the slide deck, which is on SlideShare if you guys want to click through the links. This is a great website, latency numbers every programmer should know. This gives you kind of order of magnitude comparison between how long certain things take. So something like an L1 cache reference versus reading from a hard drive are many, 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 many orders of magnitude different in how long they take. And what you'll find is almost every type of I/O. So for example, a round trip in the same data center, that's that giant blob of green in the third column. That's, 500,000 nanoseconds. Or a single disk seek, the hard drive spinning, is 4 million nanoseconds. Any kind of I/O is multiple orders of magnitude slower than anything you're going to do inside of the service itself. So any kind of memory lookup, CPU, branch, anything of that sort, it's many, many, many orders of magnitude bigger. So I/O is really expensive. And what it really comes down to is because I/O is so expensive, in this massive concurrent service-oriented architecture that we have, the threads spend most of their time just waiting. They're just idle. They're doing absolutely nothing but waiting on something to respond. And that's problematic. So you end up in this really weird dilemma with threaded servers. You don't want to create threads on the fly. It depends on the JVM and the OS and all sorts of other parameters, but generally speaking, just pumping out new threads is expensive. There's a lot of overhead with that. So you usually use a fixed size thread pool. Okay, so now you have to pick the size for your thread pool. Well, if you make it too big, you run into a lot of overhead with memory. I think the default stack size for a JVM thread is a megabyte. So every single thread, you just lost a megabyte of memory. It hasn't done anything yet. You also get a lot of context switching overhead and a few other trade-offs. Okay, but if you make it too small, then if you have too many requests that come in at the same time, you run out of threads. Now all new requests just queue up, and they just wait, and they're blocked, and your latency goes up. But even worse, and this is a real nightmare, is threaded servers are very sensitive to downstream latency. Let me show you an example. So we go back to our architecture diagram, and let's say we have a database all the way over there, one of hundreds of data stores that we have. Let's say the latency goes up. Somebody forgot to add an index on a query, the traffic went up a little bit, latency went up appreciably. Now, ideally, the only consequence of this will be the requests that directly depend on that guy become a little slower, not the end of the world. In a threaded world, though, it can actually become much, much worse. Because here's what happens. Latency goes up in that guy. Well, now the threads that are just blocking and waiting on this guy, they get backed up because they just have to wait longer. And so as, especially if the traffic just took a little spike, now all of a sudden all the threads are eaten up. And so now new requests get queued and the latency goes up on this guy. Well, now since his latency is higher, guess what? Threads start backing up on this guy, as well as that guy. Maybe that guy too, because he calls him as well. So now all of these guys are starting to have their thread pools kind of run out of threads. Latency is shooting up across the whole site. Eventually, everywhere latency goes up. And before you know it, it's a minor increase in latency in one database somewhere, and your whole site's down. And this is thread pool hell. This just sucks. You're basically trying to determine the size for a fixed size thread pool based on something that's very dynamic, which is traffic patterns and I/O patterns and concurrency patterns. It's a really annoying problem, and it's very hard. It's easy enough with one server talking to one other thing, but when you have hundreds of servers talking to hundreds of other servers, it actually gets very, very complicated. So Play is built on top of Netty, and it avoids a lot of these issues. The I/O calls are completely non-blocking. The thread will fire the request, and it'll go and start processing other things. In the meantime, that request that isn't really done, it doesn't really cost much. It basically costs a socket and a tiny, tiny bit of memory. But it just kind of puts it aside, does other things. When that response is available, picks it up again, keeps processing it until it's finally done. And so your threads aren't blocked if you write the code correctly, which is pretty important. And so you don't run into these issues where just because some downstream service got a little slower, your whole site ends up with this crazy cascading latency effect. So as I said, much less sensitivity to downstream slowness. If something downstream is slow, well, then anything that directly depends on it just becomes a little slower, but not everything. It also makes it much, much easier to do things in parallel. So if we're fanning out to 10 services to get our data, with blocking calls, we have to do some magic to make that happen in parallel. Like I said, you have to set up another thread pool that you have to manage. You have to submit work to it. You have a lot of extra work to do. With non-blocking I/O, if I put 5 calls in a row, they all happen in parallel because none of them block. It just goes to the next one almost immediately. So it's much easier to do things in parallel. And because it's so cheap to keep connections open, not just to downstream services, but also incoming connections from the browser, now we can support things like WebSockets, Comet, server-sent events, basically all of these things that are starting to power the real-time web. They're very hard to do in a threaded, like one thread per request environment. You really can't do it very effectively. You can with non-blocking I/O. And this is coming in a big way. I think Node, more than any other framework, is really bringing this up. Being able to do this on the JVM is pretty nice. Okay, so let me show you a quick example of some non-blocking I/O in the Play world. So let's create a new controller. We'll call it proxy, and it'll extend, controller again, just as before. Let's steal something from this guy. We don't really need these parameters. All we're going to do is take in a URL. And what we're going to do is we're going to make a non-blocking call to the URL passed into this action, and we're just going to proxy the result. So we can do a non-blocking HTTP call in Play using a library called WS. I think it wraps Ning's HTTP client. You give it a URL, and you can call put, post, or in this case, we just want to do a get. And what we're going to get back in this case is not just an HTTP response, that's this guy, but we're actually going to get a promise of a response. If you've worked with Java Futures, this is a little bit similar. This is an object that will eventually contain the result you're looking for. The difference from Java Futures is the pattern you use with Java Futures is at this point you would just call, you would do whatever request you want to, and then you say get. And at that point, you're blocking until that future is available. Here, we're not going to call get. You can if you really want to, and you just want to do a blocking server in Play. You can just give it a bigger thread pool. But if you want to do something non-blocking, you just tell it something to do when the data is available. And Play, inside of Play, it knows how to deal with promises. So if you remember, we need to return a result. Play has a class called, hopefully I have the source code loaded. Here we go. A thing called async result, which implements result. And this is just something you can create by passing it a promise of a result. So if instead of handing Play directly a 200 OK, you hand it something that's the promise of a 200 OK, it'll know what to do with it. It'll kind of take it, put it aside, and when that thing is ready, it'll pick it up again and send the 200 OK to the browser. So that's what we want to do. At the end of the day, we want to produce an async result. To do that, there's a nice method called async, which you can see in the return type. It'll give us an async result. All I need to do is give it a promise of a result. That's it. How do we get a promise of a result? Well, we have a promise of a response, and we want to transform this into a promise of a result. If any of you are familiar with functional programming, this is something you would typically do with a method called map or flat map. There's a whole bunch of ways of doing it. If you want to learn more about that, I wrote a whole blog post that builds the intuition about why map and things like that make sense. But long story short, we call map, and we pass it some code to execute when the data is available. And IntelliJ will generate most of that code for us. Yay. OK, so in here, I have my response. This is actually the HTTP response to that call. And at this point, I just need to return a result from that. And so we can do that by returning a 200 OK, putting the body of the HTTP response inside of our 200 OK, and we'll set the content type correctly for this request. So that's it. This is a fully non-blocking proxy in Play in, 15 lines of code. Most of them are curly braces on the next line, which are probably annoying a few of you. So let's expose that thing at a URL. And it's, let's see, controllers.proxy.index, and it needs a URL as a parameter. So if we now go here and we proxy linkedin.com, It'll reload all that stuff in the background. It'll wait for LinkedIn to respond, and ta-da, my local host is now proxying linkedin.com. And this is fully non-blocking. At no point is this server blocking a thread waiting on that HTTP response. So we can leave these connections open and do all sorts of great stuff. So it's actually pretty easy. There's not a whole lot to it. But I also mentioned that you can do things in parallel. So let's build a slightly more interesting example. We'll do one more controller. Call it parallel. Once again, it'll extend controller just to give us a few handy methods to use. I'll steal this guy. And we don't need that. OK. So what do we want to do in parallel? We want to now call several websites in parallel. In this case, I kind of want to measure how long the websites take to respond. So I'm going to do a little race between a few websites. So we'll use the WS library again. We'll pass it a URL. So how about we'll race a few search engines against each other. So we'll do Yahoo, get, oops. And if I just do this right here, this calls Yahoo in a non-blocking way. If I add a couple more guys in here, let's say Google and Bing, this is 3 non-blocking HTTP requests that happen in parallel. But like I said, I want to measure how long they took. So let's set up some code to do that. So first, I'll record when we started this whole thing. This will be a long, OK. And now what I'm going to do is I'm going to create a function that transforms the HTTP response, basically throws it away and just records how long it took to get that HTTP response. So we create another function. Oh boy, which one of these? That's the one. And it's going to take one of those response guys, and it's going to return just a long that says how long that thing took. We need one of those. Oops. And we'll store this in a variable called timing. OK, and so in here, the only code that we really need is just to basically say this took that long to process. So whenever this thing is called, take the current time, subtract our original starting point. So let's transform these things. So if I put these guys in a variable right now, you can see I'm getting a promise of a response. But I don't really want a response. I just want the timing. So to transform it, I just give it that timing function. And if I do that, this one's Yahoo. Now, as you can see, I get a promise of a long. This is something that will eventually contain how long it took to make the HTTP request to Yahoo. So do the same thing for each of these guys. Put them in some kind of a variable. This one's Google. This one is Bing. OK, almost home. The only thing we need to do now is actually do something useful with those numbers. What we can do is we can compose these 3 promises into one that will redeem when all 3 are available. And there's a handy function to do that. It's called wait all. Again, it doesn't block. It's another promise that will just redeem when everything inside of it redeems. So you just pass those guys to it. And really what we want to do, again, is use that async function. So we get an async result out of it. And let's build this as JSON. So Play has some nice built-in support for JSON. Here's what we'll do. We will put the data into a hash map. From the name of the website to how long it took. And let's just put the data in there. So yes, missed one detail here. Java, of course, has interesting ideas about closures. So data.put, Yahoo took this long. And I'm calling get here, but since this is inside of basically this guy's map function, we know it's already redeemed. This won't actually block in any way. So we'll add the other 2 in here. Here's Google, here's Bing. Let's give them the right labels. And Play has this nice function, or class, I should say, called JSON. That one. That'll just convert objects to JSON for you. And it'll set the correct content type, everything else. So this is it. This will fetch 3 websites in parallel, record how long it took to fetch them, and return it as JSON. As usual, we need to add a URL for it. that. Okay. And now we hit this guy. Give it a second to reload, to fetch the 3 websites, and hopefully spit back some JSON at us if I did everything right. Hey, there we go. All right, let's refresh one more time, because obviously this includes some hot reload overhead. Actually, no. The overhead is I'm connected to VPN. Sorry about that. So you can see Google seems to be by far the fastest, followed by Bing, and a very, very distant third is another company there. And this, you'll see, has the right content type. This is JSON. Did it all in parallel. Didn't have to set up a thread pool. Didn't have to do anything terribly fancy to make this work. So this is kind of the non-blocking story in play in a very, very quick kind of demo. Hopefully that made sense to some of you guys. All right, moving along. Let's talk a little bit about Scala. How many of you guys use Scala? Not too many. Cool. So Play has native support for Scala built right in. There's nothing you have to do to make it work. You just create a file with a .scala extension. So just very quickly, we'll do a hello world Scala. And just like the Java controllers, it'll extend a controller class to get some nice handy methods. Just like the Java version, there will be actions in here. And you also have an OK method you can call to say hello world Scala. So this is your hello world Scala example. Add one more URL. Call it Scala. There we go. So now if we go to Scala, it should reload that guy, and you'll just see it say hello world Scala. So there you go. So there's nothing really to make it work, it just works. If you put a Scala file in a Play app, it'll compile it. Scala files interoperate with Java files interoperate with Scala files. Kind of a beautiful, seamless experience. There we go. And maybe not. Showed you that. By the way, I think I mentioned this earlier. This whole slide deck is on SlideShare if you guys want to pick it up. Just search for Play Framework at LinkedIn. So one of the really nice things about using Scala inside of Play is Scala has support for a lot of nice functional programming. So first-class functions, closures, sequence comprehensions, and a few other things that can actually result in a more concise, a more composable API. And this especially applies to async coding. So the async coding in Play with Java, as I showed you guys, is pretty easy, but you still end up with that syntactic overhead of an anonymous inner class. And the reason for it is simple. To do something asynchronous, you need to have a way to say, execute this code later, execute this function later. Java doesn't really have a way to pass around a function. You can really only pass around a class, so you usually do anonymous inner classes. Scala does have first-class functions, so the code becomes just vastly simplified, which is pretty cool. Java 8 may even things a little bit here. We'll see in about 6 months, hopefully. But so the API can be nicer on the Scala side. Another really neat thing I can show you guys if you know Scala is this is the app running in the background. I can shut it down. There's an interactive console for Scala, which you can fire up. And so in here, I can run commands like 2 + 2, very exciting. But much more interesting is I can import any of the classes in my project. So I can actually import my, my controller, for example, and I can execute it. I forget what it needed, name and age. And there we go. And I get a 200 back, and there's a way to read the result out of it. So I'm literally interacting with my server on the fly in the Scala console. Really useful. I spent a lot of time here to learn how things work or to try something new. But you do need to know Scala how to use it. You have to know Scala in order to be able to use this, because this uses Scala syntax. So, oh boy, here we go again. Hopefully that's the last time I exit the presentation. Note to self, don't use Google Docs in the future. Not very good for big presentations. Okay. And you'll also find that at the core, Play is written in Scala. This is from their GitHub page. More than half the code is Scala. Java is only about 16%. Now, they have very nice idiomatic Java support for everything, but you're going to keep bumping into Scala here and there. So it's really nice if you do know Scala. So you saw the templates kind of use a Scala syntax. The routes file uses a Scala syntax. One piece I haven't talked about yet is SBT. That's Play's build system. That's entirely in Scala. So it does help to know Scala. You can be a little closer to the core of Play. The less good part about Scala is really not so much Scala as it is one particular usage of Scala. And this is a thing called SBT. This is Play's build system. It technically stands for Simple Build Tool, but I think there's some kind of a rule where if something has simple in the name, it isn't. It's really powerful. So to be fair to SBT is probably the most powerful build system by far that I've seen. It actually supports a lot of Play's awesome features like hot reload, that console, a lot of other things just come just because it's on SBT. It has things you can't do with other build systems, like introspect the build itself and execute it on the fly and other really cool stuff. The problem is it's got a really, really, really steep learning curve. If you don't know Scala, first of all, you're in a lot of trouble because the code looks like this, which I don't know if abuse of Scala is the right way to put this, but they use every possible trick in the book to really shorten things up. I don't know how many of you can guess what any of these lines are actually doing, but believe it or not, these are like function calls, and you're passing higher order functions to them, and there's operator overloading, and there's, implicits like crazy. Yeah?
Why do modern languages look more like machine code than higher order code?
That's a good quote. Very good question. So good Scala does not look like this. SBT, in my opinion, went a little bit off the deep end with abusing the syntax. So this is really hard to get started with. Again, the stuff you can do here is awesome, but honestly, like, what the hell is less than plus plus equals? Some sort of fish rocket thingy. And you can't Google it. You can't Google less than plus plus equals. You're completely screwed. So this is really rough to get started with. If you're doing simple things, like I just need to add a dependency to my app, some jar file I need, name the app, all of that is very easy. You can basically do it in a minute. But when you need to do like serious build work with Play, which we have to do as the infrastructure team at LinkedIn, you're going to dive into the bowels of SBT, and it's hard. Okay, now let's chat about performance. So I get a lot of questions of, is Play web scale? And I think there's actually a few interesting ways to look at scalability, and I really do think you're going to miss the picture if you don't look at all of them. So I think there's kind of a graph of scalability for web frameworks. There's kind of raw horsepower, concurrent horsepower, scaling for how fast a single developer can do things, and then how fast a team of developers can do things. So here's what I mean by each of those. Raw horsepower, that's like the theoretical maximum. If I set this framework up in ideal conditions and just hit it with requests, how many QPS do I get? What's the latency? How many errors? And this is largely a measure of the language and the framework overhead more than anything else. Concurrent horsepower, this is kind of a more real-world scenario. You have lots of I/O, you have latencies that vary all over the place, conditions are not ideal. This is more of a measure of how does the framework approach concurrency in general. And both of those matter, by the way. No one of these is necessarily more important than the others. There's a very strong trade-off between them. Single developer, one guy coding. How fast can he get things done? How quickly can he get started? A lot of frameworks focus on this and get this right, but a lot of them forget this one, that most things are built by teams of developers, a bunch of people working together on the same code base. The code base grows, it gets huge, it ages. How much code rot is there? How maintainable is the code? It doesn't matter if one guy can go fast if 3 months later you're totally stuck. So here are my ratings. Based on my experience, try not to get offended. Your mileage will vary. Spring MVC. If you hit this guy with a bunch of requests in kind of like an in-memory scenario, really fast, many thousands of QPS without breaking a sweat. Type safety does help reduce code rot for large, old projects, but it's not developer friendly. It's a real pain to get even the most basic thing done. And as I discussed before, this kind of threaded approach to these large concurrent I/O scenarios can be problematic to scale. So if we plot Spring MVC on a chart, represent it visually, really good in one quadrant, less good in some of the others. How about Ruby on Rails? This thing, in my opinion, kind of set the standard for a single developer in terms of productivity. Just amazing how quick you can get started, get going, and get things built. The open source community is incredible. There's a plugin for anything you'd ever want to do with Rails. But Ruby is really slow. Like really genuinely, honestly slow. And it doesn't have real multi-threading. It doesn't have a great evented architecture, so it won't handle concurrent scenarios particularly well. And it's a dynamic language, which can make it harder to maintain a large code base. Not impossible. If you do enough tests, you do enough work, it's certainly possible to have a really nice Ruby on Rails app that's big. But it's harder. It's just genuinely harder. So if I were to plot this one, it's a little bit of kind of rotating Spring MVC. It gets really good in this quadrant, really not so good in some of the others. How about Node? We actually use Node.js at LinkedIn as well for our mobile servers. So V8, if you throw a bunch of requests at it, does pretty well. Probably not quite as good as servlets, but pretty damn well. It's non-blocking, so the concurrent story is really good in these heavy kind of IO-bound scenarios. The open source community there is really good. It starts up really fast, so you can get things done pretty quickly. But it's a dynamic language, and it's a very immature framework. Or actually, Node itself is becoming more mature, but all the plugins, the ecosystem around it, is constantly making backwards incompatible changes, almost every release. And the result of it, it's a dynamic language, is you run into this when you run your app, which is a little bit too late. You kind of want to know about it earlier on. But still, it does pretty darn well on this chart. It does well in most areas, maybe not so great for huge, large projects that last many years. And so finally, play. If you bang on play with just kind of like your ideal scenario, the hello world case, I did this on a laptop. You can get like 60,000 QPS with absolutely no tuning, nothing, just run it and throw requests at it. Not a very useful test, but again, it does fine for kind of the raw throughput. Non-blocking I/O means for concurrent scenarios, again, it does very, very well. Not very sensitive to downstream latencies. Hot reload means one developer can get things done pretty quickly. I was able to write Java code in front of you in a live talk. That's impressive. I've never been able to do that before play. And strong type safety. I'd argue actually much stronger type safety than even you get in like Spring MVC, because the templates are type checked, the config is type checked, everything is just, you really know about errors very early on and in a very easy to read way. Downsides, I'm not going to claim that it's quite as productive for a single developer as something like Rails. Interpreted language, just inherently faster to reload, and Rails has been around longer, so much bigger open source community. Yeah. It's a fair question. Yeah, so for a large project where somebody else drops something in on you and things blow up in your face, Rails can actually become less productive. For me, working on my own project alone, I'm still probably going to go a little faster with Rails. And this one actually, what I would say is play is just new. And once its community gets bigger and you have plugins that do all the work for you, it's actually going to just keep getting faster and faster. But it's a very fair trade-off. It always is with dynamic languages, yeah. I don't know if that applies to the JDK, but if you're upgrading Scala versions, yes, you need play to have upgraded first. Right. That said, play type safe is kind of, I don't know if they own play or at least they provide all the commercial support. They're going to be the very first folks to upgrade Scala, long before you ever did, and probably Java too. They've been running Java 8 preview builds forever now, so that's not a concern. Yes? We own it. You own it now? Yeah, type safe. So thank you. There we go. Perfect answer. So they're going to be first. That shouldn't be as concerned. That said, the binary compatibility issue with Scala is a problem. Upgrades are inherently harder, but at least the play part is not what's going to block you. It's going to be your own code. So if we plot it on a chart, this talk is about play. What did you expect? It's obviously going to have the biggest orange box. It's probably not the best at any one area, but it's really good at just about all of them. It's a pretty effective system. Yeah. If it's not obvious, this doesn't take into account many things. I can't possibly cover every aspect of how a system scales and performs. Build system, so there's trade-offs. So as an app gets bigger, compiled languages like Java and especially Scala take longer and longer to build. On the other hand, you also get something in return, right? It's actually checking and catching a tremendous number of errors that otherwise you would have to just manually write unit tests for. So I think there is a trade-off there for a large team. I don't know who wins. I really think it comes down to the use case. But you do get something in return for the heavier build times. Can we save questions just for the end? I just want to make sure that I don't go over time so the folks that want to take off can take off. I just have one quick section left, which is just a little chat about the Play community. Play is open source. It's on GitHub, all the code, all the pull requests, all the bug tracking. Very active project. They're updating it very quickly. Very responsive to pull requests. We've actually submitted quite a few of our own from LinkedIn. We'll be submitting many more. Really active Google group. So if you have any questions, this is the place to go and ask, and it's got the mailing list behind it. And all the links, again, at the end of the slide deck. Popular on Stack Overflow, so you can actually Google things and find answers. There's a directory of open source modules. There's actually more than one, I found out today. This is growing. It's not quite as big as it was for Play 1, but growing. We've contributed a few of our own, but we have a whole bunch more coming that we'll be open sourcing in the next few months. It's supported commercially by TypeSafe. We actually did work with TypeSafe to help bring Play to LinkedIn, so it kind of has the open source part of the world and the commercially supported part of the world, which is very helpful, especially for large deployments. And the TypeSafe guys are genuinely awesome. So that's the recap. That is the story of Play at LinkedIn. It's easy to get started. It's easy to work with it really quickly. The error handling is just phenomenal. There's no more crazy stack traces. The evented, the reactive pattern is extremely useful for large deployments. Scala can make your app just really nice. The performance is great. The community is awesome. That's our story so far, to be perfectly accurate. As I said, we're just getting started. We are also new to Play, but we're excited. We want to hear feedback. We want to see what other folks are thinking about. And if you haven't tried Play, give it a shot and see if it works for you. Last piece, our engineering blog. We'll be blogging and talking about our open source code and all of that, engineering.linkedin.com. And you can also follow LinkedIn Eng on Twitter for all the latest updates. That's it. Thank you very much.